Hi there. So I wanted to go over the algorithm that you have when we've done our or we're about to do our rotation for the tree, and there's imbalance below the current node. So we're going to be going ahead and add all of those items that are in that current tree into a list. And then how do we break up that list so that in order, once we re-put the tree back together, it's balanced? What do I mean by that? If we just happen to insert from 3 to 15 in order in a binary search tree, it's going to be 3, then 4, then 5, then 6. It's going to look like a stick. And that's the last thing that we want is a stick. It's supposed to be a balanced binary search tree. So the algorithm, I'm not going to name it because you should be able to figure out what it is, but the algorithm, in order to really pull from the information that we have here and insert in a very particular order to make a balanced tree is actually very easy, and you've seen it before. This is going to be recursive, and the first step in this recursive function is when given a list, determine what the middle is going to be. Now with an odd one that we have here, we have odd number of elements, it's very easy to figure out what the middle one's going to be. It's going to be 8. If it happened to be even, so let me put my hand over, it's still there, then it would be 7, or the length divided by 2 when you take the floor of that. Anyway, so first, middle. We've identified the middle. We're going to go ahead and throw the middle into the tree, the new tree that we're about to attach to, well, the node that was before it, to make it more balanced. Step number 2 is then we're going to go ahead, because we don't want to put 8 back in there, we're going to break it up now into list in front of the middle and a list behind the middle. Now this one I'm going to run out of space, so I'm just going to put 9 ... to 15. Now I'm going to focus on this spot here because as you can see I'm already running out of space here. But my next step would be the same thing. Identify the middle. Identify the middle of this one is going to be 5. So I'm going to go ahead and add 5. Then I would break up the 2 halves between before and after the middle. So that'd be 6, 7, 3, and 4. Okay, now here's the recursion. This should look familiar. What's the middle of these two? It's going to be 3 and 6. I'm going to go ahead and add 3 and 6. Looking pretty balanced so far, doesn't it? Now, what's left over? It's going to be a 7 and the 4. But notice it's a very particular order that we're doing this in. Now, 7, okay, 4, and then 7. So that is how that tree, look at the tree. It's pretty balanced, isn't it? I mean, it is balanced. Let's put it that way. There's no one that's over 2. This is nice and full. I wouldn't say full, but it's at least balanced. Now, I didn't even get to this portion of it, but which would be over here, but that's going to be the same thing. It's going to end up, because of the algorithm, making a balanced tree. So that's why we have to use this very particular algorithm when given a massive array on how to break things down using recursion, finding the middle, breaking it into smaller pieces, and coming up with the right order to give us a balanced tree of the list given. Hope this helps things. Let me know.